Hey guys, this is part 2 of the 9.2 video series. In this video, we'll be dealing with U substitution. U substitution is a technique that you'll have to use on the AP exam, and really anytime you integrate, unless the formula exactly matches one of the formulas from the formula sheet for integrating, you're going to have to use U substitution. And U substitution may require a little bit of trial and error on your part. So in this first example, we've got the integral from 0 to 2 of x squared e to the x cubed dx. Now it's not always obvious exactly what to use as your u function. We definitely don't have a product rule when we integrate, so this is not on our formula sheet. We need to turn this into one of the formulas on our formula sheet using u substitution. So a couple of things we could try as our u. We could say, well, maybe x squared is u. Or maybe e to the x cubed is u, or maybe just x cubed. So either this part or this whole thing or this part, one of those is going to be u, hopefully. So let's see what du would be in each of these cases. Here I'd have 2x dx. So I have an x and I have a dx, but it's x squared. So what happened to the e? That's probably not going to work. If I had u was e to the x cubed, then my du would be e to the x cubed times 3x squared, the derivative of x cubed being 3x squared. So I have one e to the x cubed, but I would need another one to be there for du, so that's not going to work. But if I just use the inside function here, then my derivative is 3x squared. I have the x squared, sorry, 3x squared dx, I need a dx here, and I have the dx. So I have everything I need except for the 3. So I'm going to make this e to the u. This is going to be my u function here. So let's make it a little bit more clean. So my u is x cubed, which means my du is 3x squared dx. For those of you who do it with the method where you solve for dx, that would mean that dx is du over 3x squared. Most of you guys don't need to show that because you won't be doing that. But if you solve by plugging in dx here and then canceling out your x squareds, then you would need this. You also need to figure out what u of 0 is and what u of 2 is. This is the part that's different from when you do u sub with an indefinite integral. With an indefinite integral, you have to go back to your original equation. With a definite integral, as long as you convert the limits into u, you never have to go back. I'll show you what I mean by that. So 0 cubed is 0, 2 cubed is 8. I'm just plugging 0 and 2 into my u function. So I'm going to say, okay, I needed a 3, so I'm going to put a 3 on the inside and a 1/3 on the outside. Then I can rewrite this as 1/3. It's not the integral from 0 to 2, because I'm going to rewrite this in terms of u. I'll do that in the next step. I'm going to rewrite it real quick here. So e to the x cubed. I'm going to put the 3x squared after it. So 3x squared dx. Now we can see that this is really e to the u du. And this formula is on my formula sheet. I'm not going to say it's 0 to 2 because now that I've moved it into u, I'm going to say that we're going between 0 and 8. So when I integrate e to the u du, the integral of e to the u is e to the u. And now I'm evaluating it from 0 to 8. So this would be 1/3 times e to the 8th minus e to the 0. I can stop there, or I can say it's 1/3 times e to the 8th minus 1. E to the 0 is 1. Either of these is fine. Again, if this was on a calculator portion, which it wouldn't be, you would just hit math 9 to get your value there. All right, on to the next one. I'm realizing that I think I said math 8 in the previous video. Anyway, all right, let's do one more example before we get some whiteboards. So this one's a little bit more challenging. Whenever I see a fraction, the first thing I want to do is see if I can split it up into multiple fractions and then simplify. I cannot do that on this one because I have 2 terms on the bottom. So I'm going to need to use u substitution to make this match one of my integral formulas. So I could say, okay, well maybe u is secant squared of x. And I'm going to go ahead and move this 2 out front. I know I can deal with the constant easier if it's on the outside. If the started with u was secant squared, my du would be 2 times secant of x, and the derivative of x would be secant of x, tangent of x. So that's not going to help me get the tangent on the bottom. So that doesn't work. So let's try making the bottom be my u. So if u was tangent of x plus 3, my du would be secant squared of x, constant goes away, dx. So this is looking a lot better, because if I make the bottom be my u, then the top, secant squared dx, as long as I move this 2 out front, then I've got my du there. So I'm going to go with this as my u function. U of 0, so tangent of 0 plus 3 is 3. U of pi over 4, tangent of pi over 4 plus 3, that's 1 plus 3, which is 4. So again, as long as I convert into u, I never have to go back to x. So my answer won't have tangent or secant in it. My answer wouldn't have tangent or secant in it anyway, because I'm going to convert into a definite integral. But it's easier if you convert the limits, and then you don't have to go back to x. You can just do everything in u, as we did here. All right, so I'm going to rewrite this in terms of u. Instead of going from 0 to pi over 4, I'm now going from 3 to 4. I move this 2 out front. Secant squared dx was my du over u. This is the formula for ln, for a natural log. So when I take the integral of du over u, which is the same as 1 over u times du, if you want to think about it that way, that's going to be ln, absolute value of u. And then I'm going to, instead of an integral symbol, now it's an evaluating braces from 3 to 4. So I'd say 2 ln of 4 minus 2 ln of 3. I can leave it like this. Notice that my absolute value, so this is a u, this is a 4. My absolute value can turn into parentheses once I plug in positive numbers, because the absolute value of 4 is the same as 4. You might see this, if it was on a multiple choice, there's a couple different ways it could be simplified. So you could move these into exponents, and you could make it ln of 4 squared minus ln of 3 squared, which would be ln of 16 minus ln of 9. You could combine that and make it ln of 16 ninths. Or you might see the 2 stay out front, but combine the other 2. So it'd be 2 times the natural log of 4/3. Again, any of these could show up on a multiple choice exam, but you could stop here on a free response exam. And notice I don't have to go back to x, and I never have to plug in pi over 4 into my integrated version, because I already plugged it in earlier in the problem. So if you have a definite integral and you're using u substitution, convert the limits, and then you never have to go back to x. If you don't have limits, you'll have to go back to x in your answer. All right, so those were the examples for u sub. Why don't you guys get some practice here? All right, let's see how you guys did. First one, you don't need to use u sub at all. Just bring this 3 out front, and then either 1 over w times dw or dw over dw. When you take the integral of that, it's the natural log of w. The second one is a common type of problem to see on the multiple choice of the AP. So you have to recognize that if you use your u as ln of x, then this dx over x becomes du. So then I can just make this du over u. So the integral would be natural log again. And then when I plug in 4 and 1 instead of e and e to the 4th, my answer would either be ln of 4 minus ln of 1. This is fine, that's okay. Or you can recognize that ln of 1 is 0, so your answer is actually ln of 4. And then on this last one, we don't have tangent on our formula sheet, so some of you guys might have been a little bit stumped on this one. So what you need to do is rewrite it as sine over cosine. I added in these negatives because what I'm going to do is use u substitution, as you can see over here. if I make cosine be my u, then I can make negative sine, so that's why I needed the negative here, to be the derivative of cosine, and I can make this du over u. Instead of 0 to pi over 4, when I'm dealing with cosine as my u function, then I would have natural log. I would have 1 and root 2 over 2 instead of 0 and pi over 4. Again, natural log, the absolute value turns into parentheses once you turn in positive values, plug in positive values. This part here is acceptable on the free response, but it would be simplified to negative ln root 2 over 2. Again, you'd want to keep all of these as exact values, because if you needed a decimal value, you would just be hitting math 9 on your calculator. And again, I think I might have said math 8 in the other videos, but integrals is for math 9. Math 8 helps you with derivatives. So on your calculator, if you have a TI-84, math 9 helps you do definite integrals. Math 8 helps you find the derivative evaluated at a specific point. All right. That's it for the videos for 9.2. The vast majority of this was really just review. If the formula is not on your formula sheet, then you have to use U sub. So check your formula sheet, and if it's not there, then use your U substitution to make it match something on your formula sheet. Have a great day.